see a guy right now shooting some baskets. Doesn't seem very good, and I think maybe if I teach him a little bit about the physics behind it, it'll help him out. Come on, notice you're shooting some baskets. You want me to teach you a couple things about physics? Maybe it'll help you out?
No, not really. Kinda wish you'd leave.
Okay, looks like he's interested.
An important application of physics in the game of basketball is dribbling the ball. Understanding the relationship between the ball's kinetic energy and the distance that it bounces is necessary to gain proper control over the ball. When the ball is in your hand, it possesses gravitational potential energy, which then changes into kinetic energy as it drops towards the ground. The kinetic energy changes to elastic potential energy when the ball squishes when it meets the floor. This compresses the air molecules in the ball and causes them to have a higher pressure. The molecules then bounce at a higher rate and cause the ball to return to its original form, pushing the ball back upwards. This potential energy then changes back to kinetic energy as it moves upwards. Once it reaches its peak, the kinetic energy changes back to gravitational potential energy. If a player is not there to dribble the ball, the bounce will fade off because energy is lost each time. When I say energy is lost, I mean it is transferred into other forms because energy can't be lost. The energy isn't really lost, it just changes forms and is transferred out of the ball, decreasing the energy that the ball had when it first dropped. For example, when the ball hits the court, it makes a sound. That sound is a result of a transfer of energy. Passing is another important component of the game of basketball. Understanding the physics involved in passing a basketball can help you optimize your performance. If someone were to throw a ball parallel to the Earth's surface, and at the same time someone were to drop a ball, both balls would hit the ground at the exact same time because the gravity acting on them is the same regardless of their horizontal velocities. A well-known physics equation is force equals mass times acceleration. If you apply this equation to basketball, it will show that the mass of the basketball does not change, so it's constant. So in order to accelerate the basketball, you need to apply a certain force to it. In order to deliver an accurate pass, you have to apply enough force to accelerate the basketball enough so it can get to its target before the effects of gravity alter its path. For really long passes, it's best to project the basketball at an angle not parallel to the surface of the Earth in order to counteract Earth's gravitational effects. Newton's first law states that an object at rest will stay at rest and an object in motion will stay in motion unless acted upon by an outside force. This is true with passing because the ball will not move unless you apply force to it. The last lesson I'll teach you about is how to get up and down the court and jump around. Newton's third law of motion is that for every force there is an equal reaction force in the opposite direction. Action and reaction is what allows athletes to make their way up and down the court. When the player takes a stride, they put force into the floor. Because the floor has too much mass for the athlete to move it, the force travels back to the athlete and propels him forward. Because the floor will apply an equal and opposite reaction, whichever direction the athlete applies force will be opposite to the direction force is applied back. If the athlete's foot pushes the floor behind them, the force from the floor, called ground reaction, will propel them forward. If the athlete applies force straight down, the ground reaction will propel them straight up and allows the athlete to jump.
Yeah. 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 If I can't do it, homie, it can't be done. Now I'ma let the champagne bottle pop. I'ma take it to the top. Show, I'ma make it hot, baby. I apply pressure to pussy, the stunt and I pop.